Good afternoon, everybody. So today is the July event of our Cybersecurity Early Career Professionals monthly webinar and networking series. The July talk is from Jelena, and it's challenges to machine learning in production. So I will hand over to Jelena for your introductions and the talk. Thank you very much, Jelena.
Thanks again, Deepti. Let me move on with sharing my screen. I hope you can see it, right?
Yes, we can see.
Perfect. So as Deepti introduced, the talk of today is about challenges of machine learning. And the thing is that there are many, and we have to, go through them in a short time. So I prepared just a selection of some. But if there are some things you see that you would like to open up as a discussion, we can always do it. And it would be very interesting to see if you have others that you want to discuss about. So before we move on to the technical part, I will tell something about myself and then a bit about my journey so far. And then we go into the challenges as mentioned. So basically, something about myself is that I'm currently a data scientist in a company called Mondi Group. This is essentially a manufacturing company that is now undergoing the process of so-called digital transformation. This means that from all kinds of manual, non-automated, whatever tasks they had, we are now trying to go more into using digital solutions, machine learning, and all kinds of advanced analytics. Before this, I was doing research. I come from the academical settings, and that's how I also came to Vienna to do postdoctoral studies at the Technical University here in Vienna. And before this, I did a PhD in informatics in Lugano, Switzerland. And during my PhD studies, I was also very lucky to have the opportunity to work in IBM and Intel companies as an intern. That's something I really enjoyed. And finally, my original education is in electrical and computer engineering. That's very, very briefly about it. When it comes to, let's say, my journey from the professional side, the topics I dealt with so far and the topics I like and enjoy working in are the topics of malware detection and the topics also of face recognition, anomaly detection, failure prediction. So basically for a long time, relatively long, something like 6-7 years, I primarily dealt with topics of how can we use machine learning in security domain to increase speed of detection of attacks, to increase accuracy, to be able to build more automated systems that detect attacks. On the other side, after I joined the TU as a postdoc, I started looking at the other side of machine learning and security, and this is the area of security of machine learning. And this is now the new rising field of what is called adversarial machine learning, in which people started noticing all kinds of attacks that can actually be performed on machine learning, and all kinds of problems with the errors that machine learning does, and the explainability of the decisions it makes. And this is also a very interesting field, and we will be touching upon it because it has many connections naturally with challenges of placing machine learning in production. In terms of domains that I worked with, I really like working with constrained systems, let's say like mobile systems, embedded systems, because they are very particular for the challenges they bring. Like, for example, limited battery time or memory constraints, or simply like it's not possible to always use a neural network with a billion parameters inside, because there is no environment to support it. Other domain I worked in is communication networks, and also this is an exciting application domain with many challenges. So throughout this journey, I basically published different kind of, like publications on these different topics. I'm now enclosing them just in case you like some of the topics, you want to check like some of the work I did on these topics. But the point here is to say, the journey of researcher so far, and to say a bit like how it was, like how many publications I made. And also the very nice part of this is, of course, people I met along the road. And this I find as maybe one of the top 3 most valuable takeaways from PhD and postdoctoral studies. The people you meet at different conferences, the discussions, the exchange of ideas, and what they bring, like new ideas, new projects, new people you meet. This was a great journey with respect to that, and I really like fully enjoyed it so far. Now I would go more into the technical part. Are there maybe some questions with respect to this intro so far? Okay, I don't hear any question. So let's start maybe a new question. When we say machine learning in production, challenges of machine learning, can you think about something? Like, does something come to you as a particularly striking topic that will and should be thought about and mentioned? Okay, I don't hear. Yeah.
Just thought I'd let you know the chat seems to be disabled.
Oh, right. Just a minute. Okay.
Okay, is there
Right.
any question maybe via voice?
Right, sorry about it. Yes, please type if you have any questions, because there are a few people without mics.
Okay.
No, okay, we can move on. Yeah, ethics. Okay, right. We got some ethics. How to automate.
Yeah, great points. Great points, yes. So let me move on, and we can always stop to discuss each of these, and then maybe, some new ones that are not here. So the first one, before we go into what does it mean, I just want to introduce machine learning quickly. I imagine you all know about it, but just to say something about it is that this is essentially a great tool. And since it started in this like latest rise of machine learning, it basically changed almost every area of our life or of technology. Anywhere it started to be used was transformed into some meaningful insights and improvements. And the nicest part about it is that it is very capable in those domains where humans are not so good at. For example, analyzing huge amount of data very quickly and generating insights from this data. And this is particularly interesting for domain of security, because, for example, if you think about communication network, we have so much information incoming all the time. And automated systems that can analyze it and bring some useful insights from it are more than welcomed and useful in this domain. And another aspect that is very, very nice is that machine learning is smart, right? So in some specific domains, it already goes above human performance. Like, for example, in some domains of computer vision and some NLP domains, it is already very, very successful. And it's very interesting because it poses new challenges. Like, if it goes beyond human performance, how do we measure how good it is now? At the same time, while there are these all great advantages of it, there are also some things to always consider when we use machine learning. And the first one is that it is not a silver bullet in the sense that it does not solve all problems. It does solve some problems, but it also opens some others that then should be solved. And again, it comes with its own challenges and set of unique problems. And the last point here is that it should be used only if it's really needed, if it's suitable for the application in which it will be needed. And one example here is, let's say, to connect it with security domain is, for example, malware detection. So malware detection in most cases functions through signature creation and signature identification and signature detection. While this is, of course, it has its own limitations and machine learning is beneficial there, there is also like a big value of still using signatures because it's fast, is reliable for those signatures that already exist. And it is one area in which we should not say directly and immediately, let's just go to machine learning. So in this point, is there someone who wants to share about his experience with machine learning or anything on this topic before I go forward? Okay, so let's move on. The part that I would like to start with is machine learning and how can it be used, because we have, let's say, in industry already, but almost everywhere else, huge amount of data, and this data lies somewhere in some, like databases, hard drives, wherever. But the goal is not just to do some analysis, the goal is to bring value using this data. And this is essentially a complex thing to do. And in order to standardize a bit and facilitate this information processing from raw information to useful insights, people thought about the standard. And this standard is called cross-industry standard process for data mining, but no one uses this long name. The common name is CRISP-DM. And here is the outline of this standard, and is saying, well, this is how projects in general are being done in this domain. There is the first step, there is a business understanding saying, well, this is the problem I want to resolve, this is the data I have, can I do something? And then after this comes, okay, data understanding, does it fit the problem? Is it good enough from statistical point of view? There is a next step of data preparation after saying, okay, from this generic knowledge, I need to extract something that machine learning understands, like features that can be worked with, missing values to be removed, things of this kind. And then after this comes the process of modeling, which is basically applying some algorithm from machine learning. This is, as you can see, a highly, highly iterative process. So there are many loops here, going back to business understanding, evaluating things, again, business understanding, and so on. But after all of this is done to the satisfactory of all stakeholders, then what is happening is deployment. And as you see here, the standard finishes. It says, okay, that's it. Then you deploy it, right? But the part of deployment is actually not so simple. And there are many challenges connected with, okay, I have a good model and now, I'm essentially done. Unfortunately, this is not true. So why? Why this is a problem? And we already mentioned a couple of times that yes, somehow security features here in the deployment of machine learning, but why is it a challenge? Can someone say, or maybe write in a chat, why this could be something that we should know about?
Anybody wants to give some ideas? You could type on the chat box. There were a few newly joined people, Jelena. So, right. I think we can move on. There's no chat.
I see. Okay. Yeah. So maybe people think it's not a challenge, but let me convince you it is. It is not so easy. So I would like to start maybe with something you are very comfortable with, and saying what can happen with confidential.
Sorry, can I disturb you for a second?
Absolutely.
There's a comment from Monish. Reuse models, trust with users, providing data for mining. I think that he answered to the question, why is it a challenge?
So there is a reuse models.
And trust with users, providing data for mining.
Okay, great points. Yes, these are very relevant points. Yeah. Yes. So coming back to the three important aspects of security: confidentiality, integrity, and availability. What can happen with machine learning when deployed with respect to them? So here there is a slide, let's say, discussing what can be a problem with respect to this. And since this is the slide is not heavy, but the content is probably new or could be new, I will go through it and try to explain what is here, what could here happen. And okay, so we are now into the model is deployed somewhere. First thing that can happen is model stealing, in the sense that someone can steal your model and somehow reuse it in another way, in another place. And why is this a problem? Well, you invest a lot of time in collecting data, in training model, you develop a big infrastructure to do this and so on. And once you have a model and you want to sell it and give it to users so that you can finally profit from your investments, well, it can happen that someone actually steals it and reuses it without your permission. So this is one thing that can happen. The next thing that can happen so far, right? I mean, this is an active area of research, so all the time new problems come up, show up. But yes, so far these are the most common ones. The second one that can happen is model inversion. And this, together with membership inference attack, is a problem that your model is somehow a very, very complex and somehow comprehensive summary of the training instances you used. So having the model, or someone having the model, being in possession of a model, can infer things about the instances on which this is being trained on. And this is the topic of these two attacks, let's say, on machine learning, in the sense that in the model inversion attack, what can happen is that someone having a model and some additional information, maybe about local area in which the model was used, like which zip code of data of training instances is there, this person can somehow understand more about the the participants. It says that some certain information could be leaked, having the model on one side and a bit of a knowledge on a training set on the other side. And this is another thing. The third thing, as I mentioned, is this membership inference attack. And this is related to the fact that if the model has seen certain training instances in the training time, it is very confident about its outcomes. So this is something that has seen in the health domain mainly. And what can happen here is that, you know, your private or some confidential medical data is being used to train the model. And this model is then said, okay, this model is now, you know, is a summary of everything, doesn't reveal anything about you. But when someone has this model and uses your information, model sometimes very, very confidently says something in this sense. And this is a strong hint that you were part of the training set, which sometimes in the health domain could not be wanted, in the sense that you participated in, you know, like persons with heart problem data set. Maybe you didn't want to say it to someone, right? And somehow a model can reveal it through very high confidence on instances that has previously seen. So this is all about the confidentiality. Again, many new things are showing up like in every new conference, but this is an interesting set of attacks. The other big group is integrity, attacks on integrity, and this is what is called, most common ones are evasion attacks. And these evasion attacks I will explain next in more detail. So the main point is that someone can, you know, evade your machine learning system without you knowing about it. The final group of attacks here is on availability, and this is simply that someone, through increasing false positives, and there are ways to do it, makes your system eventually useless. Let's say, for example, you have a malware detection system and someone is managing through carefully crafting attacks, increase the false positive rate to the point that basically your system becomes useless. I see someone raised hand, so maybe we go to that if there is a question or some comment.
Yes, there are two comments. One is a question from Yedel. Can it be arranged that the user of the deploy model cannot temper it? Yeah.
Yes, this is now more and more people start thinking about it. The thing is that so far the domains of machine learning and security were somehow completely separated, and people who have knowledge about machine learning and maybe even how to deploy it don't necessarily know about, you know, how can you also protect it. And before it was not even a big problem. It says that it wasn't known, there were not so many models and so on. But yes, now each of these people try to find ways to protect. Every time some new attack comes, people also try to very proactively provide a way to protect against it. Yeah.
Yes. So there's another comment from Sandy. Design of true security and protection models for future use of health data is a comment. Then there's another comment from Monish. Making false outliers to detrain models can be an issue.
Yes, this is kind of this is an issue. It is an issue, and this is something that is, for example, here I don't discuss it because I discuss deployed model. But yes, this is a common poisoning attack in a way, that through creating some kind of careful injections of instances, you can slightly shift the machine learning decisions in one direction and lead the complete machine learning system in some way that favors you as an attacker. Yeah, these are all great points. Yeah.
Yes, I think the Sandy's comment is relevant to membership of interference attacks. It's a design of true security and protection models for future use of health data. I think that's related to that. Sandy, again, making a comment, ethics and fairness in AI, as a comment as well.
Yeah,
Thank you, everybody. Yes.
Great point. Yes, this is ethics and fairness is a great point. We will touch upon it like super briefly later on. Great. So let's go now into this evasion attack and see what can happen there. So basically, what can happen is that, well, you see, we have a scenario. There is a stop sign, and there is a human and machine learning method that see it and clearly, very confidently say, well, you know, this is a stop sign. You should stop. The trick with evasion attacks is that there is some malicious attacker, some person who is able to craft the stop sign by deliberately putting some, let's say, obstacles in a smart places in such a way that the human clearly says, well, this is still a stop sign. But due to the nature of machine learning methods, and in particular deep neural networks, if this person is smart about where to place these small obstacles, it can happen that machine learning method completely misinterprets this and says, yeah, go. This is, you know, this is a good way to go. This is a sign to go. And this is what is known as, let's say, evasion attack, the possibility to do this. And these samples of, for example, this stop sign with, maliciously added changes, perturbations, are called adversarial samples. And this is the rising topic of adversarial machine learning, one part of it, how to defend from these attacks. And this is, let's say, a big problem in the sense that now these attacks, they don't just exist. They are also fully, or in most cases, automated for computer, for images and so on. They are also automated. So even without too much knowledge on machine learning and without spending too much time, one can somehow do this using existing tools and open source libraries. And of course, people who proposed it, and as soon as was known, many people jumped on doing some defenses against it. There are some, and I'm going to go through them without too much detail, because this is, again, active area of research, and I don't want to spend too much of your time now on each and every of those. But in some, we are still not there fully in terms of how protected we are against these attacks. And the main reason is that these are challenges, very, very challenging things. And okay, so just in terms of some defenses, what people thought about is said, well, you know, if I have one machine learning system that can be fooled, what if I use 5 or 10 ensemble, essentially? It helps somehow, but is not a full defense. Another branch that appeared is called adversarial retraining. And someone said, well, you know, if I know now about the existence of adversarial attacks and I know they are adversarial, why don't I just put it in my training set, marked clearly, labeled clearly as, you know, this is still a stop sign, and in this way force machine learning to know it better. The next way is called defensive distillation, and basically defensive distillation, dimensionality reduction, and regularization, all three are in a way regularization techniques that try to prevent machine learning to overlearn. So sometimes these problems happen because machine learning learned too many specifics of a stop sign, didn't generalize enough. And all these three try to go in this direction and help with this not specifically overfitting, but non-generalization. The last point is the work we did at TU as a part of my postdoc. And there what we did is that we said, well, for some of these attacks, if we are close to, is it a stop or is it something else? Well, let's at least say that we are not confident about the decision. So we try to at least make machine learning more transparent when it is making mistakes. And this is another option. Again, this is an active area of research. If you feel excited about this topic, there is really a lot to do, and I strongly encourage you to check this. And someone who has security background is very, very welcomed in this domain. So that was security part. Now we are going into another challenge of machine learning in production, and this is something that is called concept drift. Does anyone have any idea what this could be? Does anyone want to share some thoughts on the topic, experienced some problems related to this? Is there any comment here?
Okay. Anybody wants to enable your mics and speak, that's fine as well.
Okay, I think is a bit tricky as a topic, so I'll move into this. It's not security specific and so, but this is the property.
There's one comment again, Monish. Models get out of date.
Yes, Monish, thanks a lot for being active in the discussion. You have so far all the great points. Yes, this is essentially about it. Yes, every running system that is driven on data, makes decisions from data, is somewhat, unless it's very, very stationary, for sure stationary, is facing this problem of data changes over time. And this is a big problem, because once the data changes and your predictions are static, in a way you assumed that the data is of a certain kind, all kinds of new problems arise. And one of the first ones is that essentially the performance of what machine learning was intended to do degrades. And this is something that if you don't follow, if you don't look at, you don't know. So you run your system, you believe machine learning. At the beginning, you thought it's 95% accurate, and you follow its recommendations. But at some point, you just find out, well, this something doesn't make sense. And this is a big challenge, because is now bringing machine learning to the next level. In sense that is requiring that you monitor your performance at almost all time. And it is an interesting challenge to know about, because if someone is designing something on this topic, is something that should be considered. And again, along the lines of what is the problem, what are the possible solutions, here I also put some solutions to this problem. And without now going into too many details on them, these solutions are basically saying, well, if I don't know, if I cannot monitor how machine learning does, what I can do is that at least occasionally I can retrain it. So let's say every 6 months, every 1 year, at some given interval, I retrain it. This is sometimes okay, sometimes is not okay, but there is also another way. Another way is that you basically look into the data all the time, and you try to understand the distribution of data, and then through statistical tests, you are trying to say, well, I'm now deviating from what I knew before. This is a rising call to do something. Another here, as before, this ensemble of models, they show up quickly, they show up frequently, because it is a common way of thinking, you know, if one machine learning has a problem, what if I put 5 different types out there? Does it help? Sometimes yes, sometimes no, but it is always something to try. And again, the point of this is that this is due to this concept drift, machine learning is changing, and less and less there are those static machine learning methods trained once and placed in production, and more they are becoming monitored. They become a part of a live system in which you know, many things are happening. And this is now essentially the rising field of ML ops that some of you might have heard about, that is dealing with all of these things. Okay, in case there are any questions here, please say. If not, I'm moving on to the next point.
And let's move on.
Yeah, the next point I think was also mentioned, if I recall well, in some of the discussions. I don't know if it was meant in this way, but the point is reusing trained models. And what does it mean? Basically, machine learning and AI in general is becoming very good at the specialized tasks. So you give it like very precise task and a lot of data, and it's very good with this. But in, you know, in production and in industrial settings, there are many of scenarios like this. And the challenge is now becoming, how can we generalize this a bit more than, you know, for every small problem, every variation I have, I reuse, you know, from scratch. From scratch, I run a new machine learning algorithm. And this is the challenge, because essentially every new scenario is different than the other one. So there are always trade-offs between this reusing things and starting from scratch. But in some more developed domains of machine learning, like for example, computer vision and NLP, there is already something that is called transfer learning. And through it, one can already, up to some extent, reuse existing trained models. Again, it's strongly dependent on the domain, on the on the amount of available data, but it's something to you know about as a potential way to cope with this problem in future. So in case someone who wrote this reusing trained models had maybe a different perspective, please feel free to share.
Right. Monish comes back and give an advice. Reuse generalized code, don't implement hard code.
Okay, Monish, thanks a lot for the good comment. So let's go now into the last part that I want to bring here, and this is the part of explainability. And this is essentially the core problem of one of the main problems we are seeing with machine learning in production, and one of the obstacles of even more frequent deployment of machine learning. And the trick is that the most accurate models, like these super sophisticated neural networks architectures, are very hard to explain. They are not explainable in a way that you cannot easily track how they made the decision, not like in a decision tree or something like this, definitely not. And it creates a lack of trust, and it creates an obstacle when a human has to use a model based on something like this. Because it is essentially machine learning in production is there to help human. And when there is some decision to make for which the human is then responsible, if it comes from something that is not explainable, it is hard to trust it and, you know, like set your hand on fire for it. And on the other side, because of this lack of transparency of how things are being done, there are many things, many problems with bias and unfairness so far. Again, people people work on this. As soon as the problem is known, many people try to tackle it, propose solutions, and so on. So there are many advancements in each of these topics, but it's still very hard, and we still have them as a part of what machine learning does. And the third point here is also that machine learning is, let's say, smart in when it does things well, but when it makes errors, it doesn't know, it can make completely random error. Is not really like an expert in certain topic, like a human expert, that if he is an expert or she is an expert and makes an error, at least the direction was there, right? At least something of the error is there. No, with machine learning, when there is an error, it can be something like completely off the topic. And it's still a challenge to detect scenarios like this and say, this is not something that we should consider now. Now, in terms of solutions, I just placed two. These are still not solutions, but somehow, the ways to go, ongoing efforts of the community. And one of them is LIMA system. It is now also available online. Everyone can use it. And the goal with LIMA is to somehow explain the decision of machine learning on a given instance. So rather than saying, okay, these or that features are important, once you have concrete instance, it can tell you for this concrete instance, following things mattered. On the similar topic, also the influence of different features, there are also Sharply values, and I see them like more and more used in things like a loan, assigning loan, explaining like why would someone get it, why would someone not get it, and so on. Like people started using this in order to improve on the explainability topic. Is there any question here?
Yes, Monish. Is about it's a I think answer to one of these least explainable. Isn't this because the AI implements its own code to produce the least MSE error, and people don't know what the AI did? This is dodgy, to be honest.
Yes, Monish, yes. Basically, what machine learning does is what it does and is how it does it is not non-explainable to us, in the sense that based on all the input data it has, it just tries to minimize the error, like the loss function, whatever you put it there, like mean square error or something else. And the thing is that it essentially builds a highly complex nonlinear function that in the best possible way fits the given data. So in terms of what is it, it is that, right? But if you want to now untangle what this function does and how does it do it and so on, that becomes a challenge. And if you have more than 1 million parameters in this essentially known equations, it's very hard. It actually is not explainable. You cannot visualize it. You cannot track it. It's not easy to do it. But yes, right. Essentially is that, yeah.
Thank you. We have a follow-up question. Can people change the algorithm, or do you fix the data going into it? Olivia, from Olivia.
Mm-hmm. Can people change the data?
Change the algorithm, or do you fix the data going into it? Algorithm or data, she's asking, which one you're going to fix?
Mm-hmm, mm-hmm. Essentially, everyone, especially at the design phase, it is possible to do both. You can change the data, you can change the algorithm, you can experiment more. There are even some algorithms that are considered explainable, like, for example, what I mentioned, the decision tree, where you can see what is happening in some way. In general, it is, of course, better that you use as much data as possible. So fixing data is generally considered like, yeah, why would you limit yourself? If you have more data, use more data. the problem with explainability is that there are explainable algorithms, right? So for some scenarios where it really matters, one can use those. The trick is that those, like decision trees and so, they cannot learn very complex functions. So they usually suffer on the accuracy side. So, and then if you are not accurate and explainable is another scenario. Somewhere it fits, somewhere it doesn't, but is definitely then, you know, bringing some another trade-off to think about.
Thank you, Jelena. That's all the questions from here, from the chat.
Perfect. Also from my side, that is, let's say, all what I wanted to discuss today. And if there are any other challenges you see or topics you want to bring, I think we still have a couple of minutes. Please, let's do so. I would be very happy. In this slide, I put a couple of resources that I find very, very nice. They go around these topics in a way, some of them in more depth, some just introduce them. There are also already some books on the topic. If you have any question or anything you would like to discuss now, or, you know, like at some point later in time, please feel free to reach out. I would be very happy to chat about this. And yeah, if there is something else, let's go into it now.
Right. There's a question from Olivia. In which sectors might algorithms be off the shelf rather than proprietary?
So there is a big push of, you know, in almost every sector to make these algorithms available. And this now goes into this, you know, like surveillance methods, surveillance systems, and so on. There is a push to make them available, and the big part of available algorithms is connected with publicly available training data. And for those methods where big amount of data is publicly available, people started also releasing the methods, because researchers know how to do it, right? If you have a lot of data, you train a good neural network, and then you release the model. And these are so far, to the best of my understanding, primarily related to computer vision, computer graphics, like things related to images, videos, now even like recommender systems, natural language processing things, also related to
suggestion music here, music recognition.
Yes, also music recognition as like something that would be LSTM based. So also many things related to adversarial machine learning. So for example, all the tools for the evasion attacks and defenses I showed are publicly available. So one can also profit from not just models, but also building in these defenses in the system. So this is I like it because it's becoming more and more open sourced. Almost everything, like data, tools, models, one can really quickly start with this field and make good contributions.
Any other questions? There's no questions from here.
Maybe shall I then stop sharing, and if some question appears, let's go into it.
I'm going to share my screen now, Jelena.
Yep.
Right. Thank you so much for that lovely presentation. And oh, sorry, wrong video. and answering all the questions for everybody. Right. So there's a little announcement for if you would like to join us, giving us a talk. There are very lot of people came back from a lot of answers. So I would love to have you in this event. Please get in touch with me. So, and also if you know anybody who would like to participate, who you think can be inspiring, like Jelena, please get in touch with me and put me in touch with them. So also I want to announce that next session will be on 6th of August. So it's Nacho Fernandez. He's a cyber risk manager at the Lloyds Bank, also a PhD student actually. So he'll be giving a talk on cyber security beyond classical IT. Basically, his background is in automotive sector and banking sector. Right. So thank you very much. I'm going to stop recording so we can have the continuous networking going. Thank you, Jelena. Thank you, everybody. So if anybody wants to stay back and have a chat, please feel free to do so.